So I go record, and then, so it's supposed to be recording right now. I'm gonna do the screen share, and I share. It's supposed to be recording, and we can actually, begin the lecture right now. Okay. Why is it not? Okay. No problem. Fine. Okay. And luckily today I picked a short lecture, which is what we've tried to do last lecture. I want to be able to see who is the participants with me here right now. I'm sorry, girls. I know I'm keeping you up. So I got Ibrahim Swalam. Can you hear me, Ibrahim?
Yes, Professor, I can hear you.
Okay. So sorry, guys. I apologize. You won't be able to see me. However, if there's classmates in the room, which is, and I obviously cannot ask you or force you to do something like that. But if someone would like, because I know you all like share a group or something like that, and if someone wants to join in the Zoom link and record me as I'm doing the lecture, I am absolutely okay with this. Okay, don't want to put any pressure on you. I don't want to say who's here or who's not here, so that I don't want to be putting like peer pressure on you guys. But if somebody's in the classroom and they want to do it, absolutely they can. The problem is I'm not sure if even if you see me, that you'll actually see the board behind me. So I don't think you will be able to see me anyway. So I just have to be a screen share. I think this is the best that we can do. All right, so let's begin. Let's see anyways how it goes this lecture. I know the physical aspect is important. The fact that you get to see me is also good. However, inshallah, maybe as a compromise, I mean, we'll never reach perfection. This is never going to be exactly the same way it was when we were doing pure in-class classes, but maybe it will be good enough. Okay, so I want to hear your feedback. Those of you are at home, obviously those of you are here, it's just the same as old. But if I can hear your feedback after the class, that would be very, very important. This is my first lecture actually that I'm doing inside the classroom. All right, so here we go. Let's begin. So this course is called Software Testing and Quality Assurance. Really, it should be called Software Verification and Validation, because everything that we're trying to do is we're trying to verify and validate the software that we have. If you remember, the word testing is a phase that comes in towards the end of the software development lifecycle. We begin with requirements, followed by what? I know it's still
Design.
September, but design, yes. So I can hear you well, yeah. So again, guys who are at home, please speak in, right? Don't leave your mics on, but if you need to speak, I actually encourage you very strongly to actually say things and interact with me in the class, okay? So yes, design, absolutely. And after design, we got implementation and followed by testing, all right? Now, testing comes at the end because it's something that we call a verification activity, and we'll see the difference between them. So kind of like what we'll cover in this lecture is a lot of terminology that you tend to hear around interchangeably in the industry. For those who don't really know software engineering very, very well, they will tend to use any word like verification means validation, which means testing, which means checking, which means review. They use any term unbeknownst to them what it really means. But what we'll cover in today's lecture is the difference between those terms. And really, like I said before, what the course should be called software verification and validation, because this is what we're going to try to ultimately do. However, these courses tend to be called testing, because testing is just a much more familiar term that we have in our industry, and that people outside of our industry know. I'm going to do testing. I'm going to test my code. I'm going to test this. So it's a very, very common and popular word that than say the word validation or the word verification. Okay, everybody knows what the word testing is. Okay, so we're gonna introduce the verification and validation concepts, um, the process itself, and explain the differences between static and dynamic verification analysis techniques. Right. Now, the difference between verification and validation and the word testing is that testing is a phase that happens in the software development lifecycle, and it comes after we've done the implementation. However, verification and validation is actually something that should be happening from the absolute beginning of the development, and it encompasses all the way to the end of the development lifecycle. All right. And we don't just do it on the code. This is a common misconception that the only checks that we start to do is only when we have code. That's actually testing. This is what's common to us, testing. But actually, there's a lot more to us and to this work that we do that has a place even before we get to the code level. It has a place when we get to the design. It has a place when we get to the requirements. Okay, so I come in to a car dealership and I'm a customer and I'm giving you a requirement. I said, I want a colorful car. I'm not really very clear about what I want. Okay. You didn't really verify with me or validate with me what actually car color I want. So you assume blue. I want it red. Okay. But then once you put down blue, everything else in the process, doesn't matter if it goes 100% correct, it's still wrong. Okay. So the person who writes the requirement, they put down blue, and that's wrong. And then the person who's doing the design is going to design a car that is blue, and that's wrong too. The person who's going to do the implementation is going to paint the car blue, and that's wrong. And then finally, the person who's going to test it and say, oh, is it actually blue? And that's actually that even the test itself is wrong. Okay. So what we should have done, we should have validated the product at the beginning. And when the customer said, oh, I want a colorful car, you say, what color exactly are you looking for? Okay. All right, sure, black and white are not so colorful, so we can take those out. But there's a lot of other colors that can fit in the colorful description. And then this is where the customer say, I really actually meant red. All right. So, we shouldn't just rely on testing. Okay. That we found all these issues at the testing when we should have actually fixed it all at the requirements phase. All right. And it doesn't matter how much testing we do, it's not going to fix it. All right. And it's not going to do a quick fix to the problem that we have. We have to begin from the very, very beginning again. All right. So like I said, we do it at the requirements, we do it at the design, we do it at the code level. And we have two principal objectives. Okay, when we do in V&V, first of all, is the discovery of defects in the system. All right, in other words, debugging and testing. And the other one is the assessment of whether or not the system is useful and usable in an operational situation. All right, that's it's a bit of a different concern, but here it is. Basically, we create code. You created code in SC100 and SC120 and so on. And really, our most important concern is that do we actually do a bug as we're actually creating the code. But here's the thing, you might actually write code that is actually correct, but given a particular situation, a particular setting, a particular environment, it might not work. Okay. So for example, a very, very simple example, if you take last Wednesday's lecture, there's nothing that Zoom did that was actually wrong. Okay. But given the environment that we're in, okay, and that given the environment that we're in, and that we have a very heavy traffic on the university network, then the whole Zoom session didn't work out. Okay, so I'm sorry, yeah, Zoom is great and so on, but it wasn't good enough in this situation. And ultimately, we're not blaming Zoom, but we're basically saying, ultimately, our goal, which is to perform the lecture, wasn't feasible. Okay, so you got to make sure that the environment that you're dealing with, and it's not just the bugs that you print. Okay, another example. Okay, maybe you're creating code or a software that is very usable, very easy to understand by a younger generation, but people who are in their 60s may not be able to use it very well. And the problem is you actually created a piece of software that is actually for senior people. All right. So you just defeated the whole purpose here. Okay. So yes, the code works right, but it's just not usable. Okay. The HCI principles were all shot down. Okay. So ultimately, it doesn't matter how great that software you're creating. It fails the V&V in the sense that ultimately it wasn't able to achieve its goal, which is to serve someone or a community or some sort of a business. All right. Now, terminology. The first word is validation. Okay, V and V, validation and verification. And to us, it sounds quite similar. But really, validation means, are we building the right product? Now, if you're always confused about this, remember that the word valid means, is it even possible to be an answer? Okay, so 37 degrees Celsius, that's a valid temperature, right? 41 degrees, that's a valid temperature. Okay, what if I asked me what's the temperature and I told you the temperature is ABC? That's not even a valid answer to even begin to check whether it's right or not. Okay, I could have said 37 degrees, it's a valid answer, but I might have been wrong, but it's still valid. Okay, it's a logical, it's a valid answer. Could have been 38 degrees, 39 degrees Celsius right now. All right, here's another invalid answer. Okay, you ask me what's the temperature right now, I tell you it's minus 300 degrees Celsius. That is so far off the scale that not because it's a number means it's valid, it's actually a very far off the scale that it itself is considered also invalid. All right, now what does that mean when we come to create the product? Okay, we're actually asking, is the requirements that were put down actually valid? I mean, are they directing us towards creating the right product? Did I tell you red, or did I just leave it as colorful and you make a mistake and you say it's blue? Okay, so it's validating and making sure that, Mr. Customer, do you actually mean red when you said colorful, or do you mean something else? Okay, so this is called validation. Are we building the right product? Okay, if you remember in your introduction to software engineering slides, or maybe the software in society, there's always this famous pie chart that shows the percentage of defects and issues that we run in the software development lifecycle. And it's thinking of the project management course as well. And it says, and it shows the proportion of the phases of the software development lifecycle: requirements, design, implementation, and testing, and says, where do we find most of the problems? Can you remember from that slide, where is actually most of the problems existing? It's not in the implementation. I'm gonna give you a hint. What do you think it is? It's in the requirements. And it's always because there's some sort of a misunderstanding, okay? And obviously, as we took in the requirements course as well, is that sometimes even the customer don't really know what they really want, which is part of the problem as well. So we're trying to validate with the customer, okay? Obviously, if you get a customer that knows exactly what they want, and they have the software due diligence to not say conflicting requirements, then obviously our jobs are very, very easy. But that's never the case. Okay, so we need to validate the requirements and making sure that we're going to be building the right product. Okay. When I say also building the right product, I also mean that we're building a product that the customer needs, not what the customer wants. Okay, because you tell them what they want, they're more than happy to give you a wish list. I want this, I want this, I want that. But it's not necessarily what the business needs. You need to be able to actually look beyond that. It's almost like we're doctors, and a patient comes in and says, well, I want to do this, I want to do this operation. And sometimes you have to intervene and say, no, you cannot do this. This operation could actually be harmful for you. It will do a lot more harm than it would be doing good. All right. Now, oh, sorry. When we're doing validation, so logically, when is it that we want to be able to do validation? Should we be doing it at the very beginning, or is it something that we get to do at the very end? Given what you understand about the term validation. Those of you at home, feel free to chime in.
All the time.
No, not all the time. I'm talking just validation. Okay. Are we building the right product? Is that something that I should be focusing on to do at the beginning or towards the end? Making sure that the color of the car is valid, making sure that we're starting off with the right requirements. Should that be done something at the very beginning or at the very end? Yeah, the cycle of the development. Okay, are the at the very beginning, obviously. Okay. After getting the requirements, you validate it. Yeah. I mean, generally in the early phases of development. Okay, towards the all the requirement, and obviously at the very early phase of design as well, and so on. Okay, but this is what we want to focus on, because it doesn't do us much good that towards the end of the development, hey, we realize that we actually were building the wrong product. Okay, we want to be able to do that at the very beginning before we invest any effort or any commitment towards building that software. All right. The next term is called verification. Now, verification means, are we building the product right? All right. Basically, it means we understood and we have a clear understanding of what is actually required by that product. All right. So that assumption is good. However, what I feel I wrote could be different than what I actually wrote. Okay, and this is where all the testing happens. Okay, you write code, you think it should be doing something, and to your surprise, it's doing something else. And this is where you do testing. So to make sure that it is aligned, your mental understanding of the code and what the code actually is exactly the same. Okay, so are we building the product right? Okay, so did we code it right? And naturally, this is something that we should be doing at the very beginning or mostly at the very end. No? Guys at home? Can you give me a guess?
At the end.
At the end. That's actually correct. Because unless I actually have something to check that I've actually built, I don't have anything. Okay? I don't have anything to check. Okay? So I said again, I'm going to repeat this. I understand the requirements. Khalas, we got it. Okay, it's a plus operation. 3 plus 3 gives me a 6. 4 plus 7 gives me an 11. All right. Now I'm going to build a piece of product, okay, with some code in it. All right. I know how the product should behave. I've already validated that. Now I want to make sure, is it actually behaving how it is supposed to behave? So when I actually give it a 3 and the 3, does it actually give me a 6? The only way I can do that is I need to have that software in front of me. Okay. And verification can't happen at the requirements level because it doesn't execute, doesn't happen at design. It only happens after we complete the implementation where we have code and we are seeing if what we've written is actually what we have in our mind and making sure that they're aligned. Okay. So naturally, it would be the process that happened towards the end of the software development life cycle. All right. Ultimately, basically, the V&V goals is to check that the software is fit for purpose. All right. Now the word fit for purpose is a tricky word because a lot of times we think fit for purpose means it's defect free. No. All right. And I can explain to you why is it that we are okay sometimes by having software that is defect free. Okay. A lot of you might have done some streaming at some point. All right. What if you've done some streaming, say like Netflix or so on, but you're watching a football game? Okay, imagine this. All right. Had the software been not defect free, or so if the software was defect free, then you're supposed to be getting a picture that is of high quality. Right? Now imagine there's a player who's about to shoot a penalty. They're about to score. Maybe they'll score, maybe they'll not. Okay. Suddenly, the internet connection is not as good as it was before. Might have experienced that with Netflix at some point. Okay. Now, the player shoots. The software says, "Oh, the internet connection is not as good, so I'm gonna freeze that frame and buffer, and I'm gonna keep buffering, and then I rejoin the action 3 seconds later." Well, that's no good. The shot has already happened. Okay. You probably say, I don't mind watching a lesser resolution, all right, just so I know what actually happened. All right. So having high quality picture all the time is not fit for purpose. It's actually better that we get our software to reduce the resolution and not stay with that perfect, excellent, high quality resolution in order to keep the play smooth as you see it on TV. Here's another example. Okay, here's another more even practical example. A lot of us have used Google. We've searched some keywords. I'm sure we've done that at some point in our lives. All right. Google has an algorithm that sorts the results. This is result number 1, 2, 3, 4, 5. And according to Google's algorithm, site number 1 should be order number 1. Site number 2 should be in order number 2. Site number 3 should be in order number 3. All right. But what if for them to make sure that that algorithm is performing its duties right, it's going to end up taking 10 seconds for the search results to come back. So that site number 1 is displayed as 1, site number 2 is displayed as 2, and 3 as 3. Okay. All right, great. But at the same time, you're driving away a lot of customers because they'll say, "Oh, like Google's too slow. I'm going to switch over to something else." All right. So from Google's perspective, they say, "All right, the heck with making sure that the algorithm works 100% correct. I mean, if site number 1 shows us as 1, but site 2 shows us 3, and 3 shows us 2, not a big deal." Okay. Not to mention, they'll say a customer would never actually check after us and making sure that what we're doing is correct or not correct. And you say, based on your algorithm, this is wrong. All right. So for them, a very quick response is a lot more important than a very correct response. All right. And when I say correct, I'm not correct saying from an absolute sense. I'm actually saying correct with respect to the specifications of their own algorithm, that their own algorithm has actually been programmed correctly. They say, "Oh, the heck with it," making sure that at least the results come back very, very quickly. And as long as it's within the ballpark. Okay. And they're always very, very happy to tell you at the very top, this search has been conducted in 0.035 milliseconds. Okay. Like anybody actually really cares. But they're really, what they're trying to tell you is that we're super fast. All right. So we're not trying to make sure that the software is 100% defect free. Matter of fact, we'll argue later on that we're never really 100% sure that our software is defect free. And at times, in order to do that, we'll need infinite effort to do that. All right. So at some point, we got to cut our losses and say, "Allah, enough is enough." And we established a certain level of confidence. I don't know if I remember saying this word before in the course outline. And this coverage criteria and confidence is something that we're going to keep saying over and over and over and over again in this course. Okay. So say take something like C equals A plus B. A can take infinite numbers, B can take infinite numbers. We can spend forever testing every single combination, right? But is it really worth it at this point? All right. But basically what we're trying to achieve is that make sure that the software is rather good enough for its use. All right. Is it actually good enough for its intended use? The type of use will determine the degree of confidence that is needed. Now, the last bullet point, what it's actually saying is that if this software that we're creating, maybe it's a little, a little toy game for toddlers, Fortnite or whatever, right? And let's just say it crashes. all right, because of a defect that was there. Not a big deal. It's probably a bit of an inconvenience, but it's not the end of the world. But let's pick it up one notch, okay? Let's start talking about the software defect that's in a banking system. Uh-oh, now the problem is bigger. Now the problem is actually financial, okay? And, you know, finances the numbers could be up and down, maybe 10 riyals, maybe 1 million riyals, okay? But still, it's just money, okay? Even worse, let's pick it up one more notch. What if the system was in an airplane? All right. So a defect there could be deadly to many, many, many people. Okay. So the heck with even money. We're even going one level up. Okay. We're talking about people's lives. It's a lot more important than money. Okay. So how much confidence do I need to establish in an airplane system? Yeah, very high confidence, for sure. All right. Which is going to cost me a lot of money and a lot of effort. But so be it. Because if I don't do it, a lot of people can die. However, a little toddler's game with a quacky duck and a little tomcat thing happening, you know, what if it crashes? Not a big deal. All right. Maybe the baby will cry a little bit, but not a big deal at the end. All right. So do I need to spend loads and loads of effort testing that little toddler game? Not really. All right. I can just roll it through and jump onto the next project. So the type of use determines the degree of confidence that I need to establish. All right, so VNV confidence depends on the system's purpose, user expectation, and marketing environment. Okay, this is what I just explained a moment ago. The level of confidence depends on how critical the software is to an organization. Users have low expectations of certain kinds of software, and getting a product to the market early may also mean maybe more important than finding defects. And this is very, very common. All right. First, the market in the world of software is extremely important. I mean, you see something like YouTube, who wasn't part of Google at some point, and Google, the big giant Google, tried to fight it at some point, but they couldn't. They had Google videos at some point back in 2004, 2005, but they failed, and so they ended up buying it. eBay, another example. They were the first to market the idea. Microsoft trying to come up with a similar idea. Microsoft, massive giant in the world of IT. And even then, small little eBay was able to defeat it. Okay. And I believe something else bought it. Okay. Another example, WhatsApp. Okay. Again, you got Facebook, major giant at this point. They tried to defeat WhatsApp. They couldn't. So if you can't defeat them, buy them. That's basically what it is. All right. So first to market is extremely important. The heck if it has a few bugs here or there. Okay. It's not a big deal. Okay. Sometimes it's a PR issue. Okay. Say from now we're gonna have a date set November 1st, 2021. We're gonna release a product. There's no way that I'm gonna come October 31st, 2021 and say, maybe just give us one more week. That would be an absolute PR disaster. Okay. So we'll release it. And then we will send out patches. Right? The patches, the little yellow bubble thing that pops up at the bottom of your screen. All right. And those patches are basically saying these are bugs that we haven't had the chance to fix before, but we needed to release it so that we don't face an absolute PR disaster. All right. All right. So VNV, we have two approaches. We have a static approach and we have a dynamic approach. Okay. Static approach, it's something that I'm dealing with an artifact, something that I have, and I'm checking it without actually it running, which kind of like gives us an obvious answer to what I'm trying to say is that the only thing that actually runs in the world of software is, guys at home, what is the only thing that we know that actually runs? Code. Yeah, guys, establish some confidence, okay? The answer that to the question that I'm asking is very, very easy, especially those of you at home, okay? I need you to also chime in here every once in a while. So dynamic analysis is when we are doing something, checking an artifact while it's in a dynamic situation. In other words, while it's actually running, which actually means the only way this is, the only thing that this is applicable to is the actual code. And this is what testing is all about, is running the code, giving it input, making sure that the output is as what we expect. However, we can actually be doing static analysis on code, right? Believe it or not, you've actually done static analysis on code. I hope so, at least. Okay, maybe in S100, before you clicked run, right? Obviously, you click run the first time just to make sure that it's compiling. So once it compiles, you feel like you've reached a milestone. Yay, the thing is compiling. Alhamdulillah. Okay, no more red squiggly lines. Okay, I've taken care of all of this. It's compiling. At least I got something. I can at least submit now. But after it compiles, what you want to do is, okay, you look, for example, at your if-else statement, and you check it. You're checking it on the screen. You're looking at the code. You're not looking at the little blacks, or the black box, or the white shell box that you have on your Mac to see the result. You're actually looking at the code while it's standing still. So static analysis of code is very, very important. It's a big deal. And we can figure out a lot of mistakes just by looking at I don't even have to run it. I look at the code, okay? Here I am, I have an if-else statement to check the grades, and assign grades to students, okay? 95 to 100 as an A, 90 to 9, that's an A minus. And then I'm looking at my if-else statement, it says 95 to 100, then that's an A. And then the second if-else statement goes 90 to 93. I notice that 94 is not there. So without me running the code, I know this is gonna fail, okay? But that's one thing, that's called static analysis. When we click run, we're not actually looking at the code, but we're actually looking at the result of executed code. This is when we're doing dynamic analysis, all right? So static analysis come in the forms of software inspections, reviews, and walkthroughs. All right, that will be the topic of our next lecture. All right, which we probably might actually begin with today. And dynamic analysis, big part of which is testing, but we're going to look at different also techniques that kind of like precede testing as well. And that will be a big chunk of this course. Okay. So static analysis, like software inspections, reviews, and walkthroughs. Okay, they're concerned with analysis of the system in a static situation to discover problems. Okay, given that it is static, I can apply it to the code, but I can apply it to other things as well. I can apply it to the design document. I can apply it to the requirements. Okay, helps me quite a bit with validation, right? Just reading the requirements and saying, there's something here doesn't sound right. Something here is missing. Okay, the 3 C's. Remember the 3 C's of requirements? No? Speak up, guys. 3 C's of requirements.
Complete.
Correctness.
Concise.
No, not concise. Complete. Consistent. And the most important one.
Correct.
Correct. Yes, absolutely. Good job, Sadhu. Okay, so complete, correct, consistent. All right. Another place where we actually can do static analysis, believe it or not, is the actual tests that we create. All right. So I'm looking at a test that is supposed to test an add function. And the way the test is written is that I give the system inputs 3 and a 3, and it's saying that the expected output is 7. Okay. The test itself is wrong. I mean, what is there to say that because it's a test, it has to be correct? There's nothing that says that. Even the test itself could be wrong. Okay, so poor software is producing a 6, which is the correct answer, and then we still mark it as a fail because we've actually written the test itself wrong. All right. And this is something we're going to talk about a little later on when we cover the V model, which is coming up in a few slides now. Static analysis could be supplemented by a lot of tool-based tools, that they check documents and they do code analysis. And some of the things that you look for is what we call bad smells. So even if you don't find a bug per se, they can say and looking at the way you're structuring your code, that's really a recipe for disaster. So please restructure it again. So even if the behavior hasn't changed, okay, at least the internal quality have improved. And that's what we call refactoring. Sometimes improving the structure get us to reveal and actually see a hidden bug that we didn't see when we had a nasty looking piece of code or a poorly structured piece of code. Okay, so dynamic analysis, on the other hand, is mainly concerned with software testing, and it's mainly concerned with executing the software to get it to in a dynamic form, and then all of the testing that happens in the world is mainly all about giving an input and making sure that it's producing the right output that we are expecting. The only maybe exception to this, things like relate to stress testing and performance testing, where you're not really checking a particular output, but rather you're basically trying to see a particular network or a particular service, how much can it handle? And this is called stress testing or performance testing. All right. You can, if you really want to, put it in terms of a pass and a fail, saying, well, the server should be able to handle, say, 1,000 connections simultaneously. And then if it handles only 900, then it failed. And if it handles more than 1,000, then it passed. So if you really want to put it in that term, then you can. All right. So static and dynamic V&V in the software development lifecycle. See in the middle here, you guys, you see that the dark orange is the development lifecycle. You got requirements, and we do some design, detailed design, all the way to the programming. And basically, at the very beginning, we create a prototype. Remember from the requirements course, we create a prototype, and the purpose of the prototype is not to create a product, but it's actually to go back to the customer and say, hey, are we on the same ballpark here? Am I getting a correct understanding of what the heck is going on over here? Or am I completely way off? Okay, so this is what we use prototypes for, okay? And then as we go through the development life cycle all the way to the code, we do the testing and making sure that the program that we've created is right. We can do inspections on every level, okay? Inspection, okay, just muraqba, okay? And we look at anything that we have, we can put our hands on because it's a static thing, and I can do inspection of my requirements, my design, my actual code, and so on. All right. But the program that I'm testing, this is where we do something dynamic. Some prototypes, did you use Azure in 221? Use it, huh? Right? So that's an example of a dynamic prototype. So it's not necessarily something that is just sitting there, standing, doing absolutely nothing. So that could be a form of dynamic V&V. All right. We need to plan for V&V. V&V shouldn't just be happening, shouldn't just be an ad hoc. Planning should start at the very beginning. And we need to have a balance between static verification and dynamic V&V, okay? Which leads us to a very common model, and it's something called the V model, okay? Now, I know it doesn't look like a V, but if you take that orange middle, which actually kind of looks like an arrow, and you kind of like, you take the box where it says module, unit, code, and test, and make that at the very bottom, kind of like rotate it 90 degrees clockwise, okay? Then you'll kind of like see the V happening, all right? Those of you at home, can you see what I'm trying to talk about? Okay, where you have that last orange box saying module and unit code testing, you just flip that so that this is at the bottom, then you have a V, okay? Now the whole purpose of the V model, and it basically says, when I'm writing the requirements, and I'm trying to make sure that I understand it correctly, what's one of the best things that I can do to make sure that a concept that I understand is correct. So we have this happen since we were in grade 1. A teacher comes in, explains something to us, and the first thing that they do is they start to give us examples. The example is a concrete version of what they've just explained. All right. So instead of me spending like an hour explaining what an add function does, or you take the first number, then you add it to the second, then I'll start to give you examples, right? And it's our job actually as software engineers to come up with those examples, okay? And basically, let's just say you're assuming you're trying to explain to me this very complicated add function, and for some reason, I'm just not getting it. I have no idea what the heck you're talking about, all right? But I think I feel I'm getting the hang of it. So what I do is I come back and I verify my understanding, or should I say validate my understanding by saying, okay, so this thing that you're talking about, if I give it a 3 and a 3, does it give me back a 6? And you'll say yes. Right? If I give it a 10 and a 5, does it give me back 16? And you'll say no. All right. So you remember making sure that it's doing what it's supposed to do and not doing what it's not supposed to do. Now, this effort that I put in to come up with those two examples, what better test can I create after I've actually developed the product than to use those same examples that I've given to my customer 6 months ago when I was sitting down with them at dinner and making sure that I understand them correctly, than to use those same exact examples. Okay, so when I actually create the code, what better test can I give it than to give it the 3 and the 3 and making sure that it actually is giving me a 6? Give it a 10 and a 5 and make sure that it's actually giving me a 15. All right, so let me just see if I can do this. Guys at home, can you see the mouse? Huh? Can you see the mouse moving in front of you?
Yes.
Okay,
Yes.
so here I am at the requirements, right? While I was having dinner with my customer, and I wrote down 3 plus 3 equals 6, and I wrote it down on a piece of napkin. Instead of throwing that napkin, let me put it down and archive it, so that later on, after the development have completed, okay, and it's gonna be put into service, I take that napkin that I put in my folder and I test the actual system that was created. Okay, so, and I do the same thing in every phase. Okay, so when I get to do the design, I can create tests to make sure that my design itself is right. And then when I get down all the way to the unit, all the way to the very end, I create tests to make sure that that little unit is actually working correctly. And the whole point is, I start off by a small little component, making sure that that component itself is working correctly. Okay, like a hinge on a door in a car, just make sure that that thing is working correctly. And then after you make sure that the hinge is working correctly, right, you make sure that the hinge is working with the body of the car. And the next level up, making sure that the door with the hinge, with the body of the car, as the car is moving, in total, everything is working correctly, okay? So I have a piece of software, it has 3 functions, F1, F2, F3. What I do is, I take F1, which is the last box that you see in the V model, and I just make sure that F1 is working right. So I give it an input and check its output. Later on, before I connect it to F2, I take F2 on its own, isolated, and I give F2 input and make sure to check its output, make sure that F2 is working correctly. And then the next level up is to take that F1, right, and connect it with F2. So basically, I'm gonna give an input to F1, which at some point is gonna pass a value to F2 or call F2 to do something, maybe return back to F1 and then check the result. So now, not only that I have checked F1 and F2, but also check that they can communicate with each other correctly. And then we move on to F3. First of all, I do it in isolation. Then after I do it in isolation, I connect it to what I already have connected, which is F1 and F2 as one bigger unit. All right. So I do here at the bottom, the checks for the unit. Now, when we were having that dinner with my customer, I did not know I'm going to have an F3. We're talking about general concept. We're talking about requirements here. Okay. So when we get down to the unit level, and I have actually created an F3, then and only then can I think of a test for it. All right. Again, 6 months ago, when I was having dinner with my client, I did not know that I'm going to have an F2 talking to an F1. All right. That's my design. All right. So only when I created a design that says F2 is going to talk to F1 that I've actually created a test to get F2 to talk to F1. All right. And then at the very, very end, and you can see this thing is expanding. All right. Really, the actual tests that I was talking to and talking about with my customer is when F1 was talking to F2 was talking to F3, all the Fs are talking to each other and the whole system is running as one big unit. So the whole car is moving. All right. And the things that customer asks you about a car, can it turn left? Can it turn right? Can it pause? And so on. It doesn't actually say does piston 2 move up when piston 3 is going down. That's the specification, by the way. But no customer actually asks that. Okay. So this, in a nutshell, is the V model. We get to do quite a bit of that in this course, in that we will begin small. Okay. We will begin small, and then we'll move on to connecting things together and testing things at a larger level. All right. This is also irrelevant to black box testing and white box testing. You might have heard those terms before. Black box testing is when I have a unit, doesn't matter how big or small, and I don't look inside, I just give it an input and an output and check that its output is correct. White box testing means I'm gonna create a test, but the test that I've created is through my understanding of what that unit does. Okay, now, back again to black box testing. My inception of a test, ilham that I get for creating a test, is by actually reading the requirement and say, well, based on the requirement, I'm going to give it that test, make sure that it's working correctly. Which kind of tends to mean that white box testing tends to be more relevant to the smaller units, whereas black box testing is more relevant to the bigger units. In theory, you can do white box testing on the big unit and the small unit. And in theory, you can do black box testing on the big unit and the small unit. There's nothing wrong with that. All right. However, to check every single little component and how they interact with each other of our big component is very expensive. It's not so expensive when I'm checking the internals of a small component. All right. So we tend to do a lot of white box testing with the small units, but when we bring in the bigger units together, then we start to do black box, black box testing. And this is what a lot of companies do. Okay, so a car like Mercedes, before it puts the car together, it takes each one of those million little components and it makes sure that each one of them on its own works correctly and is of very high quality. On the promise that when I put them all together, because I've already checked every component well, that when I put it all together, it's going to give me a quality product. Okay. So I don't have to check the internals of every little component in my product after I put it together. Where's the thing? All right. So any questions about this this material, guys? Those of you at home, I think this is the last slide of that. Yeah, there it is. Any questions about today's lecture? Sorry, this lecture, because we still have more. Okay. Normally I would have stopped here, but because we already stopped last lecture, we couldn't have last lecture, so we're just going to move on to the next slide. Yes, at home, can you please raise your voice a little bit?
I have a question, Doctor.
Yes.
Do you have an example that we can apply this V model on, so we can better understand
We'll
the
absolutely
modules.
be doing a lot of those. ما تستعجلش. This is just the first lecture of the year, but we're going to be doing a lot of this as we move forward.
Okay, thank
All
you.
right. Okay. But عموما عبد الرحمن, do you understand like kind of like the concept that I've explained? I know I don't have the concrete examples yet, but do you have, at least the concept, does it make sense?
The overall idea, yes, but it would be better to
Okay.
have a rigid
Of course.
example.
Of course. Of course. Well, this is what the whole course is about. It's just a 4 note for the whole course. And Faye, Banan, Sadoun, everything is clear. Okay. So again, because our last lecture was a bust, unfortunately, I will just stop this for a second. And those of you at home, can you just verify with me that what you're seeing in front of you is part 2, software inspection, reviews, and walkthroughs?
Yes.
Okay.
Yes.
Okay, good. So part 2 is where we discuss static analysis techniques. The most popular of which is called inspections. And inspections is the most formal of those techniques, whereas reviews and walkthroughs are less formal. I kind of like what you've already been doing in your SE 100 and 120 classes. So let's begin. But that's part 2 is the only part of the course that talks about static analysis. The rest of the course, so kind of like maybe after half of this lecture, or the half of the next lecture, that we'll be doing dynamic analysis from now on till the end of the course. All right, so some of these static techniques require teamwork, which means that we're going to be doing some meetings, and meetings could get feisty. All right. There tends to be a clip that I tend to show my students at this stage. It's a funny clip from a talk show where the guests are to fight with each other. But I don't want to be switching back and forth between the different screens. So I guess you get the gist of it. It's a very delicate art. Once you graduate, inshallah, and you get a job, and you maybe get a job at a big company where you have a lot of meetings, a lot of useless meetings, you will walk into these meetings and things will get tempered, because ultimately at some point you're going to have a different opinion than somebody else, and somebody else is going to think that you're silly, and you're going to think that somebody else is also silly, right? And what happens is that a lot of people take offense, take it personally, and think if I'm attacking your idea, that I'm actually attacking you, which is not really necessarily the case. But there's no way you can avoid it, and these fights tend to break out. And we're going to pay some special attention on the inspection process as well. So walkthroughs, reviews, or inspections, they're a form of some human-based testing that involves people working together. I'm going to begin with some basic axioms regarding meetings. First, as we all know, meetings can be terrible. All right. If you haven't been to a bad meeting so far, you will be. Okay. You might have actually already had like a feisty meeting with your classmates while working on a project. Maybe not. I don't want to get into that. But for meetings to be effective and we get any benefit out of it, it has to be a safe environment. Safe to attend and safe not to attend as well. So you don't want to be people coming in because they're forced to, or they're intimidated into coming to a meeting. One way to accomplish this is remove uncertainty about what this meeting is about. There's nothing scarier in the world when you have your boss calling you up for a meeting and say, I want to meet with you on Thursday at 1 p.m. and not letting you know ahead of time what this meeting is about. Your mind wanders for days. What did I do wrong? What did I do? And usually, if they don't tell you ahead of time what this thing is about, usually they have terrible news to tell you. Okay, whether they're going to attack you, whether they're going to fire you, or something like that. Okay, they want to publish an agenda and stick to it. Okay, sticking to an agenda is a lot easier said than done. This is where all these TV hosts make all this money, by making sure that the person who's talking to them on TV who's not trained or or have a degree in journalism per se, that they're actually sticking to what the talk show is about. So sticking to the agenda. It's very easy for someone to take a meeting and take a detour, take a left turn, and the meeting loses its focus. You need to be able to handle emergency issues in a way that will not hurt people who don't attend the meeting. All right. This tends to be not a big deal. This is basically saying that, you know, whoever is there should be and should have the level of authority that if there's an urgent decision to be taken, can be taken. Now, with with the internet and all that stuff, we can always get in contact with the person who's not in the meeting, unless they're on a flight or something like that. But even then, even flights now have Wi-Fi. Be sure people who attend are identified and are explicitly invited in advance. Okay. You send a general invitation. People who should be coming start to skip. People who shouldn't be coming are showing up. You don't want that. Gently confront those who should not attend to leave. Usually, it is a very rare situation that somebody wants to butt into a meeting when they're not invited. Okay, it can happen, but okay, and usually because of some political agenda or something like that. Okay. Another thing, you want to establish some ground rules in the meetings. For example, a no interruption policy, some time limits, so that others can participate. And again, it requires a little bit of a charisma. It requires a little bit of a strong personality to make sure that these rules are enforced. I have been to meetings here at Al-Faisal that hasn't gone so well because of time limits, and people who are controlling the meeting are not really in control of it. So not just Al-Faisal, but actually in other places as well. It's very, very important to outlaw personal attacks. That definitely gotta stop. Okay, no personal attacks, no put downs. Put downs is very similar to personal attacks. Now, there's nothing wrong with criticizing somebody's idea or say discussing it, saying maybe this will not work because of such and such and such. But a put down is really, and it's almost an insult to the person themselves by saying, "Oh, your idea is stupid." That's a put down. And if you just leave it as your idea is stupid, it's really the same thing as saying to the person, "You're stupid." Okay. Now, if you tell me, "Well, your idea might not work because we've tried this before," and the flow of and you're talking to them at an objective level, they'll get the idea that you're not attacking them, but you're actually, in a very civilized manner, criticizing their idea, which is fine. Got to finish on time. Nothing puts people off in a meeting, and even attending future meetings when you tell them that the meeting is 1 hour and takes 2 hours. User-related issues list to ensure follow-up for important off-topic matters. All right. Sometimes somebody wants to take the meeting to a different direction. It's not the time for it now. So you say, we'll talk this offline. But sometimes what they're actually saying is important. It's not like say, oh, it's not the topic of this meeting, so we're just going to dismiss it. So yeah, just bring this up. Have offline meetings if you really have to. Meetings should be as small as possible, but not any smaller. We've covered that already. Keep the agenda short. Been to so many meetings before where there's 12 items on the agenda and we have 1 hour to complete them. Guess what? 55 minutes into the meeting, we're in item number 2. Okay. Practically, you never cover thoroughly any agenda point more than 2 or 3. Okay. Unless you have a lot of what we call communication items, where it's not really an agenda item, it's just something you're informing others. And if that's the case, there's no point of having a meeting to begin with. You could just email them this information. Okay, you're not really getting their input, just telling them something. All right. And a lot of times what happens, and this is a trick, you might also want to be paying attention to this when you get into the industry. Sometimes you'll see agenda item number 11 and 12. They have some, not so clear, or should I say, risque sort of items that the meeting conductor wants to pass through the committee. But had they been discussed thoroughly, they probably won't pass. So what they do is spend 55 minutes talking on the first 2 points, and then they go, okay, 3, 4, 5, 6, 7, 8, 9, 10, let's pass quickly, okay? And this is kind of like one way to not give something a lot of time and a lot of spotlight, because if that happened, then it would have been rejected. So in other words, to get it accepted, you sell it. That's what we call, you say it in Egypt. I don't know if you have the same term here or do you? Sell it. كروت يعني. When you do something like really quickly and it's just you're doing a half job. Okay, what is the term that you use here? Like when you do like a half job to do it really quickly. طبطب ليس يطلع كويس, huh? Okay, that's actually very similar to something we have in Egypt too. It's called عبكو ليس كله كويس. And if you didn't understand, I said, you're probably not gonna understand the second one. Anyway, be prepared. Want to be facilitator because basically you don't want to end up being a fish market, everybody yelling at the same time. Okay, so everybody is looking at one person to guide the meeting. Be prepared. You have no idea how many meetings fail because the person who's called the meeting is themselves not prepared, or the people who are in the meeting not prepared. Okay, so we're gonna meet today to take a decision on the case of certain person. All right, we're supposed to come and we spend the hour discussing the case after we've understood it. But again, you get a lot of people coming in saying, I didn't even read the case. All right, so take 45 minutes to read the case. All right, so that just ate up 45 minutes. You're only left with 50 minutes, okay? Maybe we don't have enough time for it. So being not prepared, okay, or for something, we got to make a decision on such and such, okay? And then somebody will say, well, this is based on the demand numbers, the supply numbers. Where are the demand numbers and supply numbers? The facility said, well, I don't have them. Okay, well then once you have them, let me know, and then there's no point of continuing this meeting. So walkthroughs, the first one is usually done in a single meeting. We want to find any bugs, any alternative implementations. Not necessarily something is wrong, but maybe I can do it a little bit differently. You realize to yourself, if you happen to complete the assignment maybe 24 hours before the assignment was due. Evaluate conformance to some standards. Those standards could be programming conventions that relate to a particular programming language, or it could be just conventions and standards that are set by your own company. And it could be rather informal, no formal training required. And the success or failure of it, the efficiency of it, really depends on the skill of the person who is doing the walkthrough. Okay, so an experienced programmer would be doing a better job than an inexperienced programmer looking at a piece of code. Now, more or less, walkthroughs is what you've actually been doing with your ST100 assignments. Okay, kind of like you look at it on a big screen, right? You don't have any structured approach. You just literally just using your finger and tracing through the code line by line and making sure that maybe everything adds up. Okay. All right. Standards could be set by your professor saying, well, if you have a constant, it has to be all capitals. So you make sure that it is all capitals. Okay. And the middle point is, okay, I used an if else statement. I could have used, I used a do while loop, but I could have used just a regular while loop or a for loop. That's a different alternative. Okay. So walkthroughs can be performed at any phase of the software development process, which means it can be performed on requirements, not just the code, design, the actual tests. Next up, we have inspection. Now, inspection is a lot more formal than walkthroughs or even reviews. Okay, and inspection is a very, very systematic machine type of work. So much so that a lot of the work that we do can be performed by machines, right? If you can program it to do so. All right. And the whole point behind inspection is that I have the artifact that I'm going to check, and I'm going to have what we call a checklist. Okay, things that I need to look for. Okay, for example, one of these things that on a checklist could say every variable needs to be initialized. And basically, you're looking and saying, oh, int x, and then you see colon, oh, that's not initialized. Then you flag it. You don't correct it. Your job ends when you flag it. That's your job. Okay. Another example on the checklist. Every constant needs to be all capitals. Again, you see constant int x, and x is a small letter. You flag it. Again, you don't correct it. You're not looking for solutions. You're looking for violations only. All right. So we have a checklist, and then we have this thing that we're checking. Could be use cases, could be any requirements artifact. Most commonly, obviously, it is code, a design document, and so on. Team members need to have some training beforehand. So issues that are uncovered by inspections usually could be then in itself a symptom of something bigger. So when that constant variable was written in a small variable, a small letter, it was maybe because at some point the programmer thought that this was an actual varying variable, not a constant variable. Okay, and that assumption could lead to bugs later on. Its success depends on the properness of the inspection process application. So we're going to talk about the application in a moment. It's a process, and if it's done correctly, it will yield some good results. If it's done not so correctly, it will yield some bad results. The second thing is the checks applied. So in the last slide, I was saying a checklist-based approach. So I have this artifact that I'm checking, but I'm also having a list of things to check for in my checklist. What if this thing that I have has just like one item or two items? Well, I'm not checking for much here, sah? All right. So if that check was proper, it was good, it was decent, and you'll be applying some of that in this course as well. So yeah, fun stuff. The other thing is the diligence of the people working. Diligence in the terms of somebody who's doing the checks is doing it properly, bizimma, all right? Or somebody who's just, you know, just doing it, skimming it very, very quickly. Okay, nobody's gonna figure that out. But yeah, you're compromising the process in this sense. Also, the diligence comes in the form of the experience of the programmer. Now, we said in the walkthroughs, the person who's doing the check, if they're like very skilled and very experienced, they probably have a much better success rate than somebody who's not so experienced. But also the same thing applies despite inspection being a very mechanical and taking away the human aspect of it, and it's a very mechanical thing, still the person who is doing the inspection, if they are experienced, if they are skilled, they probably still have better success rate than a person who's not. All right. So let me give you an example, right? Something that relates to مثلا use cases. Remember, an include relationship can only exist between use cases and each other, right? An association can exist between an actor and a use case. Remember these good old days? All right. Now, let's just say I brought in somebody who knows nothing about use cases, and I'm told them to look for association relationship between use cases because that would be a violation. They have no idea what an association looks like. Okay, The other thing too is that they might be looking at the wrong place. Maybe looking for association between axes. Whereas you would be focused on looking at the right places because you're well versed in the technique of use case modeling. Same applies in programming, same applies to design documents, same applies to whatever artifact that you're looking at. Inspections can be performed at any phase, and again, it can be performed on any document, a requirements document, a design document, classes, tests, even tests themselves could be subject to inspection. When you are doing an inspection, the checklist needs to be specific, okay? It's very common that somebody reads something on a checklist to look for something in the artifact that we're checking. It's actually not clear and it's not precise what I'm actually asked to look for. All right. Team members must be familiar with the organization standards, all right, because that usually finds its way on an inspection list. Inspections will increase costs early. However, later on, you reap the benefits as you're actually saving yourself a lot of trouble at the very beginning. So any effort that you tend to do in the requirements phase to save a lot of bugs, a lot of issues, tends to have a much, much higher reward at the end. Whereas if you skim at the beginning and you don't put that much effort into your inspections and so on, you tend to pay the price higher, see the blue line, without inspection later on. Okay, and actually this graph doesn't really do it much justice. That blue line gets to be a much, much fatter line, much, much higher line towards the end than if you don't do it with inspections. Than if you do it with inspections, I mean. All right, so now the process itself. There are some key people involved in an inspection process. The first of which is the moderator. So the moderator is the person who facilitates the whole process, and they're the boss, they're in control. And they tend to coach also other people about inspection and how they should work, okay? They should be technically competent. I don't know if it's just